Alright, welcome back to some more geometry. Today we're talking about three-dimensional figures. Let's kind of go over some verbiage that we'll be looking at. So we're talking about common polyhedrons. That's just a generic name for three-dimensional figures. So when we talked about two-dimensional figures, we call them polygons, meaning multiple sides. Well, polyhedrons mean multiple surfaces, so they're enclosed in one range. As you can see right here, our surfaces can come in different shapes and sizes. We got what we call platonic solids, our prisms, our pyramids, and then we'll later also talk about our non-polyhedrons, what makes them different. So most polyhedrons have what we call faces, which is the flat sides, our edges, which is where the faces meet, and of course our vertex, where the edges meet. Now certain ones, depending on what kind of polyhedron we're doing, we have a specific one called a base. The base kind of helps name our shape. So for example here, when we look at our prisms, we got a triangular prism, a square prism, a rectangular prism, a pentagonal prism, a hexagonal prism, and an octagonal prism. As you can tell, these are named according to this particular face right here. So we call that a base. They're called base. Same thing with our pyramids. We have the bottom of the pyramid, so that kind of the base of the pyramid, it names them square, triangle, rectangular, pentagonal, hexagon, and octagonal. No, if we look at these down here, these are called non-polyhedrons. If you had to guess why do you think they're called non-polyhedrons? Again, like we said, polyhedrons means multiple flat surfaces. Well, as you can see right here, some of these surfaces are not flat, especially on a sphere. So we look at this right here, and we of course have these non-polyhedrons, like we said. Now, as we specifically said earlier, we have these called platonic solids. We won't deal with them too much in this lesson. This is just an introduction to the whole thing. But these are special kind of solids because if you look at every single one of these, the face is the same all the way around. They're all congruent faces all the way around. So our cube is a special kind of solid. We call that a platonic solids. But if you look at all these, there's a pentagon, but they're all pentagon. We use a soccer ball is a good example of a dodecahedron. And this right here is multiple triangles, squares, so on. So the majority of today's lessons, we're going to be talking about surface area and volume. So you see surface area is the amount of surface on the outside of our shape versus volume, which is the amount of space on the inside. So we'll start with our prism. Our prism is going to be our first one we're going to talk about. We're talking about prisms are made up of two bases. So that means there are going to be two sides that are going to be congruent to each other. This triangle is a perfect example because when we see our solid, in the example we're going to do, we see this rectangular prism. So we call the top and the bottom our bases. But sometimes our prism lays sideways. So our bases are on the side, but it's still considered the base of it because that's what the shape is named. So the very first problem in your homework is a triangular prism, so the triangle is your base in that case. Alright, so let's look at the formulas for these right here. So all prisms are done in the exact same way. So we start with surface area. This big P, anytime you see a capital letter, it represents something else. So big S is talking about surface area. Well, surface area is made up of what we call our lateral area and our base area. So let's talk about pH right here. pH, capital P, little h. Capital P stands for the perimeter of the base. So we're looking at the distance around one of the bases, our perimeter, and we're going to take that times the height. Now, back in the day, my son's working on this. When they do this earlier in elementary school, you find the area of each individual face, and then you add them all up. Well, they said, instead of having to do that, let's kind of think of it as we're looking at all the lengths of every single one of these faces at the same time, and then we're taking that times the height of all of them, because they all have the same height, because that's the height of the entire solid. So big P takes perimeter, so we're going to be adding 1, 2, 3, 4 sides. We're going to add them all up, plus, and then we're going to take that times our height value, as we'll do here in a bit. And then that right there gives us what we call a lateral area. If you remember what lateral area was, it's the side area. So that's going to give you this area of all the individual 4 sides here. All the individual ones, all the sides here. Alright, and we're going to add the two bases because we're missing base 1 and base 2. So then we add the area of the two bases. The base changes according to the prism. So for us on this one, you would do a rectangular base. So that's a length times a width down here, and that gives you the area of the base. And you have two of them. When you do your triangle one, you got to do the area of your triangle. So this formula right here for B will be base times height divided by 2 for a triangle base. In that case. For volume, let's look at volume. Volume is a little more simple. It's area of the base times the height of the whole thing. So like kind of seeing how much it fills up. So let's kind of practice this problem. So we'll start with surface area. Our surface area is equal to our perimeter, which would be 10 plus 5 plus 10 plus 5, because we're adding all. You can go ahead and assume that these are the same. We're going to add all four sides. And we're going to take that times 6, which is the height of the whole thing. There. And then we're going to go ahead and add the area of the base. Now this is a rectangle, which is base times height, or length times width, however you want to call it. So we will do then 10 times 5 for that. We add all this up, we get 30 times 6, and then we're going to add that 2 times 50. We end up getting 180 plus 100, which gives us a grand total of 280 units square. Now this is area, so even though it's surface area, so it's units square. Let's look at volume. Volume is a little bit different. That's where it's new to this chapter, or new to this lesson that we haven't seen yet. So here we're doing area of the base. Again, that is a rectangle, so we'll do base times height of the base. And we're going to take that as the height of the entire prism. So we say there's two heights, but there's the face, which is base times height. That's what we also call it, length and width. It might help out, length and width, and then times the height. So we get 50 times 6, which gives us 300. Now this is in units cubes. We call those cubes because the idea behind this is there is a little cube that is a 1 by 1, 1, 1 that's right here in the corner, and we want to see how many cubes can we put all up in here. In this case, it's 300 of them. Let's look at pyramids. Pyramids very similar to prisms, but they only got one base, and these times the faces are different. They're all triangles. If we looked at our prisms, all the faces are rectangles, rectangles everywhere. But pyramids, they're all triangles. Just like the prisms, you name them based off the shape they have at the bottom. So let's look at that. So the formula as it goes is 1/2 perimeter times L. L stands for slant height. You can also see this exact same formula as S equals PL over 2. So you can write it like that as well. I give you both of these because you will see them both. Same thing with the volume. Volume can be written as area of the base times the height divided by 3. As you can see this, we only have the one base. So that's why instead of having times 2, we have times just a base. And we're still talking about the perimeter times a slant height. When we do a slant height, the slant height is for the surface of the perimeter, so surface area. And then we have a height on the inside. That's also called our altitude. That one's used for volume. So think about it. If the height is inside, it's volume. If the height is outside, it's surface area. So let's kind of do this one as an example here. So we say surface area equals our perimeter. So if this is 6 and they only gave us 1, we can go ahead and assume they're all 6. This is a square. So that gives us 24. We got that by adding all four sides. We're going to take that times our slant height, our 5, and that's all over 2, plus the area of base, which is 6 times 6. All right, luckily 2 goes into that, giving us 12, so we end up getting 60 plus 36, or just 96, to be units square. Again, we're talking about area, so be units square. Let's look at volume. Volume, you do area of the base, so it would be 6 times 6 times the height. This time we're doing the 4 instead of the 5. We're doing 4, all divided by 3. So we end up getting 36 times 4 over 3. 3 goes into 36 12 times. We end up getting 48. 48 units cubed. Now somebody asked, is it normal to have the volume sometimes smaller than the area? Yeah, it's okay. There's no, because there are two different types of measurements. This is the cubic measurement versus a square measurement. So to the square measurement, the surface area may be huge, but it's a small space. So hopefully that makes sense. Let's look at a square. Square is a special kind of pyramid, and we bring square up because you'll run into problems like this, where it says, hey, you got this square right here, right? And let's say they're all 4s. So 4, 4, 4. If one side is 4, they're all 4. So for the area, you'll say, hey, well, that's just 6 times 4 squared. So we square the 4, we get 16. We take that times 6, we get 96 units squared. And for volume, it's even easier. You say volume equals 4 cubed. So that's 4 times 4 times 4, which gives us 64 units cubed. Right? So what if the problem says, hey, I know that my volume is equal to 125 units cubed. I want to know my area. Well, Well, we got to figure out what the length of one side first to find the area. So we say, all right, so 125, what can we do with that? What can we do with that? Now remember, the volume is 125, so that means 125 also equals my s squared cube. So, all right, I need s cubed. So how do you get rid of a cubic? You cube root it 3 times. So you ask, what number do I multiply 3 times with itself to get 125? Well, if you're not sure, you can kind of just say, well, let's reduce that. So 125, I can divide that by 25. That's 25 times 5. Well, then 25 is made up of 5 times 5. Well, if you look at this, I got my 3 5s right there. There's my 3 5s, so that means I can say that S is equal to 5. So now that I have that, I can put that in my other formula, 6 times 5 squared, which gives me 6 times 25, which gives me 150 units squared. That's my area. You'll have a problem like this on your test, so be mindful. Make sure you got that down. Let's look at our cylinder here. So the formula of a cylinder is very similar to that of a prism, except we have to compensate for the roundness. So, but the idea is to behind it. We're still taking the perimeter times the height plus 2 times the area of the base. But the perimeter is a circumference, so we use the 2 pi r. Okay, the height's still height, and then we're taking 2 pi r squared being the area of the base. So let's look at that real quick. We'll have, we'll do this problem together. We'll have S equals 2 pi, our radius is 9, and our height is 20. Okay, plus 2 pi radius square, or 9 square. Again, keep your answer in terms of pi unless you get a round. So 2 times 18 times 20, that gives us 360 pi. Hope that's right. Plus, this gives us 81 times 2, that gives us 162 pi. You add them up, you get 522 pi. That's a pretty good, acceptable answer, unless it tells you to round. Okay, remember, don't round to the very end, you get the round. For volumes, look at volume here. Very similar to that of a prism. It's area of the base times the height. Remember, base is a circle, so you just use pi r squared. So volume is equal to pi 9 squared times 20. So we get pi times 81 times 20. You end up getting 1,620 pi units cubed. Again, leave it like this unless it tells you around. I do know for sure on the test they're going to ask you to use 3.14. So get it to this point and say, all right, 1,620 times 3.14. And there's your answer for a cylinder. Let's look at a cone. A cone, similar to that of a pyramid, only has one base. So this is our one base. And this is our perimeter times slant height divided by 2 per se. But then it got reduced down to that point. So let's look at this particular problem right here. Remember, still have slant height, and we're going to use 3, 4, and 5 as our numbers here, as our example. So you can pause and try yourself, but let's look at it together if you can. So let's say surface area is equal to pi radius slant height. That's a 5. Make sure you use a 5 here, plus pi radius square. So we say surface area is equal to 15 pi plus 9 pi. We put them together. We end up getting 24 pi units squared. Pretty simple, right? Let's look at volume. Volume is the same way. We say, hey, volume is equal to pi 3 squared times the actual height. So just like the pyramid, slant height's for surface area, actual height is for volume. So we'll do 4 here. That's all over 3. So we end up getting pi times 9 times 4 over 3. That 3 reduces the 9 to a 3, giving us 12 pi. That is a good, acceptable answer. You can leave it as pi and you'll be good right there. Let's look at our last problem. So as we look at spheres are a set of point that goes all the way around a center point. So when we talked about circles on a two-dimensional figure, it's the same thing. All these are a bunch of little points that go around the whole circle. But a sphere is in three-dimensional concept here. So let's look at the formulas for sphere. So as you can see right here, our formula is based off just the radius. All we need is a radius, and then we can figure out everything out. So let's look at our area formula. Our area equals 4 pi radius squared. Make sure you square that radius first. Now the volume, it's the same picture, it's the same formula right here, but one is written differently. So I provide both of them so you can see them because they will be given to you one or the other. Sometimes the state test will say 4/3. Sometimes they'll say 4 pi radius cube over 3. But let's look at the main difference besides the 3. Besides the 3 down here, is this 3 right here. On volume, which is 3-dimensional, you have to make sure you cube your radius first versus the r square, where you square it. So as we do this problem right here, we'll say for volume, we'll do volume first. We'll do 4 pi times 7 squared. Make sure you square that first. You do 4 pi times 49. You multiply the 2. You get 196 pi units square. Okay? Leaving it in pi is a perfectly acceptable answer. Let's look at volume. Volume goes 4 pi 7 cubed. 7 cubed divided by 3. So when you've got to cube your 7 first, you'll do 7 times 7 times 7. So 7 times 7 times 7. We get 343. So we got 4 pi times 343 over 3. So we'll do 4 times 343 times 343. We get 1,372 pi. And then because it doesn't divide evenly, you can leave the 3 on the bottom and call that units cubed. That's a perfectly acceptable answer. Hopefully this helps. You guys have a wonderful rest of your day. Bye.